storage again here in this zone, because the data is not correlating and not matching with the delta P. And again, I'm seeing there is a dip here, and then the hump comes, and then there may be IRF region later. So, but there is a disturbance in the data, so we would like to smooth it. So for that, we will use the deconvolution approach. So for that, again, I will reduce some noisy data by using 0.2, suppose. Smoothing factor as 0.2, so we will use this, run. So again, you can see it has taken consideration the best points. So now we will run it. Okay. So this is the graph I'm getting after deconvolution. So you can see this carefully now. This is your line to actually identify the IRF region and the slope for Valvor storage. So I'm using this. You can see in Valvor storage, I'm not seeing any line which can actually, or you can do alternatively, you can actually right click and see for storage. Again, if I draw this line, there is no line which can match with this unit slope line. Okay, so I can use this, I can use this also. So there is no unit slope line in the early ETR zone. So it means there is no Valvor storage in this again. So again, there is a hint, if the Valvor storage is not there, again, this may also be the case of fracture. Okay, so now you can also see the pressure data. It is actually showing only the PBU2. So we are talking about PBU2. So it is also similar to the previous one, and it seems to me like there is a fracture. And based on this interpretation, I can say that IRF will occur later here. But there is one more line which is actually touching this, which is actually giving the slope 0. So this seems to be very smaller IRF, but after that we have a hump. Okay, then the main IRF will come later. So it seems that there is a small zone which is also showing some storativity, and because of which I am having a small IRF region, IRF regime also in this zone. So this is the, and again there is another hint that there is no Valvor storage. So it seems to me that in our ETR I have a fracture, and it has significant amount of storativity. Therefore, pressure transient will give some stabilization for smaller time in fracture zone also. After that, there will be transition, and then we'll shift to the main reservoir, and it will come later. Okay. So I mean, based on the graph, I'm just making some points, some just based on the understanding or based on the theory fundamentals. I can see these things is, I mean, this is the possibility with the interpretation. So interpretation may have these possibilities. Okay, but we'll now actually model this, and we'll see what could be the answers, so that we can actually confirm if there is any fracture or not. So I have a question here, sir. How we concluded fracturism? I mean, there are so many. I mean, there are some hints with this. First of all, once you start modeling the graph, once you model this and then improve it, then you will have the skin value should be in negative. This is actually the very straight hint. But based on the interpretation, I can see that this zone in ETR is giving me something which we should interpret here only, because I told you that in ETR we will see the first Valvor storage, it is not visible. Then there should be a hump, and hump is seen here. But before hump, there is actually no Valvor storage, but a small, there is one small this reason which is giving me IRF regime for a smaller time. You see here, there is a line which is actually matching with this zero slope line. So I can make a guess that there is a one more zone which is giving me IRF. It means this zone also has a storativity. So it may be linear composite, or maybe some other reservoir near to the well. But there is one more hint which can identify that this is actually fracture which is having storativity, and this is actually the wellbore zone, wellbore storage region. So from here you can identify that there is no wellbore storage. It means it is fracture. Or second interpretation or second confirmation will come when we will improve this, when we will model it. So permeable, sorry, skin should come in negative. So this is another hint to identify, to understand that this was the fracture region. So let us, any other question from anyone? If you have any question, please let me know. This is very, very fundamental interpretation that you have to first, I mean, yes, of course, software is there. We can actually model it and then we can improve it and we can find the answers for the customers. But as an engineer, first we should try to understand what kind of shape this graph is giving to me. So let us make some interpretation before coming to the final conclusion. So based on this interpretation, I can find that there is no wellbore storage. So when we will model this PD curve, we are not going to use the constant wellbore storage model. This is the first hint. We will use the no wellbore storage, and based on the interpretation, I can directly tell from the graph that there is no wellbore storage. Again, there is hump, and then I think some IRF will come later. This is in MTR zone. So it is just based on the understanding or the theory fundamentals which we have seen. So I'm just making some guesses, and based on the guess, I can make a guess that this zone in ETR, I think, is a fracture, because it is giving a fracture storativity, and because of which I am having IRF in fracture for a small time. Then it is also not actually giving me wellbore storage in ETR. It means it's. I mean, I think more than I can actually make a guess with 90% probability it's a fracture. Okay, so let us confirm this. So now we will model it. So in model, we will use the standard model as we used yesterday. Now, instead of constant wellbore storage, I can use no wellbore storage. Okay, so wellbore storage will not be there now. And the well we are considering vertical, homogeneous, and infinite. So let us generate. Yeah. So once you generate it, this is the actually your first I mean model, which is giving me these graphs, and it is not at all matched with the actual data. So we will improve it. So let us improve it. So improve may just run. Let us see what will happen to the data. Now after improvement, I am seeing these graphs. This is the improvement. So now I can actually move it, these lines over the graph. So similarly, you can do when you will have the chance to work with the software. You can also see these lines can be moved easily. And so as Amir was asking, so first answer is giving me skin in negative -7.2. It means, or in the permeability is very good, 186 millit RC. It means the guess which we made initially was, I think, right. Okay, because the skin is in negative, it means it's a fracture. Now I can do what? I can again try. I will again try to improve it. So what I can do, you can see this dotted line which you are seeing is actually the IRF region line. So I'm trying to shift it here, and let us see what will happen at this point. Improve it. Run. So now again, it is actually permeability slightly improved, 290 millit RC, and skin is still -7. Again, you can shift it, and then you can again try if something will happen or not. Let us try at this point. but it is again coming minus 7.11 290 millidarcy. Like this, I can also see here. This is also, it is not entirely matched here, but it is reasonably matched in this zone. So you can again shift, you can do so many changes in the graph by shifting it here or there. So like that, I can actually make the corrections, and then I will see if there is any further correction in or the improvement in the data. Again, it is coming 7.11. Let us try with this. Again 7.11. So the model is giving me the best answer in this zone, in this region also for these values. So this could be the best interpretation, and these could be the best values for the second PBU. It means the PBU for both of this data. There is one more question, sir. On what basis is this shifting of the model done? Actually, I'm trying shifting means what? Actually, I'm shifting to match with my actual data with the prediction of the model. So model have predicted these things, because you can understand model has already considered it's a fracture. So the red one is del P line and the white one is the del P dash, and it is already showing me that it's a fracture. So what I'm doing, I'm also taking these reference, these graphs as a reference and trying to match my actual data. So I'm trying to match my actual data with this, so that my MTR can have a best fit with the predicted line. Okay, the actual data will try to actually match with the predicted line. So for that, what I'm doing, I'm improving every time. So once you again improve, it will, you can see it is giving the match of this kind, and in which we can say that it is a reasonable match with the predicted model of the software. So I can take this as an answer. So that's the basis. Or again, you can, if you can actually try further on, you can match this also with the red one. So then more tuning will be there. So I'm just trying to tune and trying to find the best answer from the this software or from this facility. Again, you can shift here or there and here or there. So then it will automatically adjust the values. Yeah, okay, sir. There is a lag after every step. Okay, okay, Amir, I'm going slow. So I'm actually trying to again one more time to match it with the my actual data with the model predicted values. So let us try again here. Let us try this and improve it further. It is again showing the same value, minus 7.11 and 290 millidarcy. Look at the MTR line also. This is also giving me the reasonable match. So I can take this as an answer from the software. Okay, so this is the final interpretation of the PBU of the second PBU. I mean, interpretation of the second PBU. So you can understand both the PBUs have confirmed that there was a fracture, and I think skin was also closer. It earlier it was for the first PBU it was, I think, minus 7, and it is again minus 7.11. So this like this we can actually interpret the information, and we can do the then model, then improve, and try to have the best answer. Try to interpret the graphs in the best way. Okay. Anything from your side, because this was the second example of the last example. So the first PBU I already discussed. Today I have discussed the second PBU. Both the PBUs have confirmed that it was the fracture, and the permeability was also reasonable. It's a good permeability. So there are so many signs to understand that it is a fracture. The permeability is very good. There is no well bore storage. The skin is negative. So these are some of the hints from which your expertise will let you know, okay, this is happening. I think this is happening. I think this is happening. So based on your expertise, based on your thinking, based on your knowledge, fundamentals, you can actually make initial guesses with the interpretation. And then finally, when you will have the answers and your guesses can actually match. Yes, there is one more question. What about two humps? Yes, two humps. Can it not be dual porosity or linear composite? Where are the two humps, Amir? Where are you seeing two humps? Are you considering this as a hump? This one? This one? If you are considering this as a hump, then I think it should not be I mean, if you consider this as a hump and make a case with the dual porosity, you just look at the life of this. Yeah, there is no well bore storage, of course. So I'm entering into the fracture, of course. I'm entering into the fracture. First, when there is no well bore storage, the first indication that this is a pure case of the well bore. I mean, this may be fracture. This is the first case. So in dual porosity or the linear composite, if you are talking about the linear composite, then I think this may not be at the same level. These are some of the thinking. This level and the next IRF level will not be at the same. Or second, if you are going ahead here, so this may be the supposed mobility ratio between the two composite reservoir, and this is the first. Then I'm going ahead. Then I'm going again back. So this zone, of course, Amir, can be considered as a part of the composite reservoir, but the initial in ETR, I'm not having the convincing answer, I think. So for composite reservoir, well bore storage may be there, but here the well bore storage is not there. So if yeah, from software, yes, you can confirm this when you model. So when you model, you can sometimes if you look at the data also. Let me show you the data. Like, yes, this is a good question, sir. How can we confirm from this software? So when we will have the example, sometimes some information will always be given to you. Like the next example, I'll show you that some of the informations will always be given to us. It's not like that we are going to scan the complete reservoir or complete problem without having any problem. Oh, sorry, without having any suggestions, without having any data. So some of the informations, initial informations will be given to us. Yes, like for example, you may have the limited entry well. So the this limited entry zone thickness, the height of the zone from the bottom may be given to you because these are the constant things that may be given to you. So based on this data, I can understand, okay, I have already a data. So instead of using homogeneous model, let us use the two porosity sphere, two layers, radial composite, linear composite. Some information will always be given to you. So from the customer or from the data, you can also find, like the next example I'll show you, some of the information will be given to us. So the information will clearly say, okay, we are talking about here a limited entry well. So if it's a limited entry well, it means there should be a spherical flow of the negative slope. So these things, when we will incorporate, we will not use the homogeneous model. So we will use the different model. Like in well model, if I look at the vertical, there must be here vertical limited entry. So from the software, you will always have a help like vertical limited entry. If you click on vertical limited entry, there will be so parameters which you will now feed, like HW, ZW, KZ upon KR, which is a permeability contrast in the horizontal and in the vertical direction. So these things will be asked by the software. So at least HW and ZW should be given to us, because these things cannot be solved by the software. These things should be given to us. Then only I can actually use this. So this can be confirmed from the software also. Accordingly, you will use the same model and feed the data, and then you will have the best interpretation. Anything else? So this was the interpretation in a vertical well. And one more thing, if unless and until the customer is, or the problem is not giving any hint or any data, don't change the model. Like if they are not talking about the suppose horizontal well, so I'm not going to use the horizontal well. I will use the always vertical well, because it is not told to us like this. There is one more, fractured horizontal. So if they are not talking about this horizontal well, at least every time you, suppose I'm asking every one of you, like you are going to do suppose well test in a horizontal well, at least reservoir drilling engineers, well completion engineers will definitely let you know, of course this is a horizontal well. So this is a horizontal well, so at least this information should be given to us. Only then I can use the accordingly well model. Otherwise you are not going to scan the entire system. Some information should always be given to us. So people will let us know, okay, this is horizontal well, these are some of the properties you should know, because this will help you to interpret the well test data. So based on this, I can select the model. I can help the software to make the correct guess. Okay, anything else? Any other question? Because after that, at 4 o'clock, we will start the very good example. And in this, you will see that I can change the parameter. I will show you this example will be for a specific problem. Like they will tell you already that this is the case. And in this case, just interpret the well test data and give us the best results. Okay. So if you have any doubt regarding this, you can again let me know. I can repeat if you have not understood anything. The problem is that you cannot actually handle the software by your hand. So if you have any, suppose once you come here, then you should have you should visit the CCIS lab and try to understand how to use this by hand, and try to upload the data which you have. Suppose you may also have, like last semester or last semester, there was a guy who was having some data from ONGC, and we use this academic software to interpret the data. But unfortunately, we could not publish it because it was not the commercial software, and we don't have the permission also. So, but we interpreted based on the this data given by the ONGC, and so like that you can also interpret this directly from the software. But problem is that you cannot publish it anywhere. Okay. So and then once you are here, just visit sometimes CCLS, open it, and at least try to understand how to use the software, how to load Q, how to load P, how to extract DP by your hands. Okay, because online I can only tell you how to actually do these things, but you will get the better feel once you come here and use the software by your hands. Anyway, if there is no more question, then we'll meet at 4 o'clock with the next example. Okay. Bye everyone then.